find the binomial expansion of 7 minus 2x all cubed. Now, we could do 7 minus 2x times 7 minus 2x times 7 minus 2x, but I'm going to use the binomial theorem. So the binomial theorem says this: a plus x to the n is a to the n plus n to c1, and then what you do is you reduce the power of a by 1, and then you introduce an x. So the next one will become n to c2, a to the n minus 2 times x squared, and it carries on until you get to x to the n. Okay, not a to the n, x to the n. Right, now another way of getting these is to use Pascal's triangle. So a will be 7, and x in this case will be equivalent to minus 2x. So it's going to be 7 cubed. Now you need to make sure you use brackets. nc1, so it will be 3c1 of 7 squared, so the power gets reduced by 1. Then in brackets minus 2x. Because it's x to the 1, so x is minus 2x equivalent to plus 3c2, 7 times minus 2x squared, and then the last term will just be plus minus 2x cubed. We know we got to the last term here because this last one must be minus 2x cubed. Right, 7 cubed is 243, 3c1 is 3, 7 squared is 49, and then I'm just going to put minus 2, and then I'm going to get x, and then 3c2 is 3 as well, times 7. Now, minus 2 squared is plus 4. And then I've got x squared. And then here I'm going to have plus minus 2 cubed. Minus 2 cubed is minus 8 times x. It's probably worth your while doing that step so you don't make a mistake with the sign. So it's going to be 243. This will be minus, but when you multiply these together, you're going to get 294. Make sure you put a minus sign. The next one will be plus. 3 times 7 times 4 is 84. It's x squared, and then minus 8 cubed, okay? This is not the only way you could do this question. Of course, you could expand free brackets. So you could, instead of using these, you could use Pascal's triangle. So this has been a video to show you to expand a cubic using the binomial theorem. I hope you've understood, and I thank you very much for watching.